Australian scientists are on the cusp of constructing human body parts using 3D printing to reproduce a patient's own skin cells. Researchers from St Vincent's Hospital in Melbourne and the ARC Centre of Excellence for Electromaterials Science in Wollongong are behind this breakthrough. And the centre's director, Professor Gordon Wallace, joins me now from our Melbourne studio. Professor Wallace, thank you for your time on Newsday. Can you talk us through this incredible work you're currently doing and just where it's up to in terms of 3D printing of human tissue?
Yeah, so we use really conventional printing technologies in order to create quite exquisite structures. So we build up using a printer, build up very sophisticated structures using layer by layer deposition. And some of the challenges there when you're tackling biological issues, of course, is to transfer through that printing process very delicate biological molecules and even living cells through the printing process. And we've had some breakthroughs recently on a number of fronts in terms of new bioinks that can deliver functional cells and also new inks that can deliver biomolecules and polymer structures to keep everything in place.
How far away do you think we are from printing organs and making the idea of a need for an actual organ transplant, as we know it today, obsolete?
So at the moment, with our colleagues here at St Vincent's Hospital in Melbourne, we're targeting two applications. One is printed conduits for nerve repair, and the other is printed conduits for muscle repair regeneration. Our target is to get those applications working within the next 5 years or so. In doing that, we will put together and develop both machinery and protocols in terms of materials, chemistries and biologies that'll really lay a very strong platform for us tackling the challenge of replicating the function of human organs. So it'll be subsequent to that 5 years, and how far subsequent to it, maybe another 5, but look, the rate of progress in this area is staggering. In the last 5 years, the convergence of a number of technologies in things that seem quite diverse, like printing and material science and biology, and of course working with our clinical partners, all of those things coming together have enabled progress in the last 5 years that we would not have envisaged 5 years ago.
So I understand that for many in the medical field, they don't like to put dates on things, but I have heard it quoted that by 2025 it's feasible that you will be able to fabricate complete functional organs.
Yeah, look, I think that is feasible. There's a few challenges, a lot of challenges to be overcome. We're taking steps both on the technical front and equally as important on the team building front to make sure that we have all the skills integrated into the team to go for those sorts of targets. And the technologies are developing so rapidly that I can see that things will be technically feasible. And if we can get the right collaborative environment where we can blend all of the skills together, that of course will accelerate progress as well. And that's why it's important that we do establish the facilities like we have today at St Vincent's Hospital here in Melbourne that's taken developments out of what we could call a material science, engineering, biology lab in Wollongong into a real clinical environment. That's going to help us accelerate progress just as much as progress on the technical fronts.
And just finally and briefly, I understand that other countries are investigating this type of technology as well, but you've asked for funding in order to make yourselves a leader in this area in Australia, I understand. Should that funding come from government, or do you think it can come from the private sector with such incredible research?
Look, I think it'll have to come from government and hopefully some from the private sector as well. What we're proposing here is really very exciting. It's to develop the Aikenhead Centre for Medical Discovery here in St Vincent's. Wollongong University would be a critical partner in that. What it's really going to do is create an incredible training environment for the next generation of researchers in this area, and they're the guys that are going to set the timetable. They're the guys that are going to make it work, and if we can get them into the right environment for their training, that will really accelerate progress in this very exciting area of medical research.
Professor, I do thank you very much for your time on Newsday. We've appreciated that, just incredible, fascinating work. Good luck with it.
Thank you very much.
Professor Gordon Wallace there speaking to me from Melbourne.